This is a screencast on how to classify numbers by factors and multiples, including primes. Now we're going to go over what each of these things mean, a factor, multiple and a prime. But in the meantime, all you need to know at this point in time is just to remind you that to classify something means to put into groups. So you should be able to look at numbers, any numbers, and go, okay, that's going to be a factor, that's a prime, and so forth. And you should be able to calculate which one it will be. So, let's give it a go. Let's begin with factors. Okay, so a factor is what a factor is in maths is it's where you multiply by another factor to get a product. For example, if we had the problem 6 times 4 equals 24, then the 6 and the 4 are the factors. So these are important things to know, because it's important to know that if you multiply this number by another factor, you get the product. So we're going to look at how to find out the factors, and also with that find out the primes in the next part. Now let's imagine that we had the number 36 and we had to make a list of all of the factors that it has. So numbers that it can be multiplied by to get 36. Okay, so take a moment to consider that. Here are some examples. We've got 6 and 6. We've got 3, 12, 4 and 9, 2 and 18, 1 and 36. So that gives us a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors for that number. Where a number like 3 only has 3 and 1. Now let's use this number 36 and let's factorize it using what's called a factor tree. Factorize it. So let's take this 36 number and I'm going to factorize it. So what are two numbers that multiply to equal 36? So I'm going to go 2 and 18. Then from 18 we've got 9 and 2, and then 3 times 3 equals 9. And we're going to look at these numbers here specifically. I'm circling them for a reason. Let's try that again, but let's, rather than using 2, we're going to use 2 and 18, we're going to use 4 and 9. So that takes us down to 3 and 3, and that takes us down to 2 and 2. Reason is 2 times 2 equals 4. Two numbers that equal 9 are 3 times 3. And this one here, and if I circle those numbers again, and this one here, 36, and this time I'm going to do 6 times 6. And I get 3, and I'm going to get 2, 3, and 2. And again, I'm going to circle these numbers down the bottom. So I'll just quickly go back over what I did here as I went to factorize something, two numbers that multiply, two factors that multiply to equal that number. Now I can't use 36 and 1. Well, I could, but we didn't in this case. 2 and 18, and then 2 here, because I can't go any further because the only things that multiply together to make 2 are 2 times 1. So I went here, and I went 9 and 2. Again, I got stuck here. But then I was able to go, well, what two numbers multiplied to equal 9, 3 times 3. Over this side, I went 4 times 9 with the two factors I chose. And then I went, okay, what two numbers multiplied to equal 4? Oh, 2 times 2. And then here, 3 times 3 for 9. And so forth in this one here. Now you'll notice that these numbers are all the same. The ones that are circled, 2, 2, 3, 3. 2, 2, 3, 3. 2, 2, 3, 3. These numbers I've circled here are what are called prime numbers. Now, a prime number is a number that can only be multiplied by 1 to get, it doesn't have any other factors except for multiplying itself by 1. So let me say that again. A prime number is a number that doesn't have any other factors except by multiplying it by 1. So if you go back to the 2 here, you can't multiply anything to get 2 except 2 times 1. Same with the 3. So it makes them prime numbers. So let's have a look at a list of numbers here. Which of these numbers here are prime numbers? Which of these numbers can you only has the factors of itself and 1? The answer to this question is 17, because it doesn't have any other factors except 17 times 17 and 1. If you look at 16 here, it's got 4 and 4, 2 and 8, 16 and 1. 15 here has 5 and 3, and 12 has 3 and 4. So prime numbers, let me just say that again, it's a key part, are only numbers that have as its only factors as itself and 1. Multiples. Multiples are probably the easiest one of these three to understand. And a multiple is, all it is when, if we were to take the number 5 and we multiply it by 2 equals 10, so 10 is a multiple of 5, and of 2, but it's of 5 in this case, because we multiplied it by another factor to get a product. So we could also say 5 times 3 is also a multiple of 5. So let's take that a bit further. If you think of skip counting, it's a very simple way to see what the multiples are of something. So if I take 3, I can go 3, 6, 9, 12, 15, and ... All of these are multiples of 3, because we have 3, but then we have 3 times 2, which equals 6, 3 times 3, which equals 9, 3 times 4, which equals 12, and 3 times 5, which equals 15, and so forth, and so forth, and so forth. We can go 6, 12, 18, 24, 30, ... If again you can see 6 times 2 is 12 is a multiple of 6. So I'll just say it again, it's when you multiply it by another factor. When you have a number and you multiply it by another factor, that product is a multiple of the first number you multiplied the factor by. So let me just recap. A factor is equal to what is multiplied to make a product, i.e. 6 times 4 equals 24, 6 and the 4 are factors. A prime number is only a number that has the factors of itself and 1. And a multiple is equal to a product, i.e. 36, is a factor of 6, because you can multiply the 6 by another 6 to equal 36.